The second primary function that we use 3D printing for is for tools and fixtures. This is one of my personal favorites because I think there's a lot of advantages to using very specialized tools to make work easier, both here at gym when we're assembling parts and out in the field for you, the boater. So this is just a small example of one of our gym locks with a tool that we use here for we're going to do experiments with the gym locks. We want to remove the rivets. It's just a fixture that holds it. Pretty simple, but this is the type of thing that's very easy and fast to make with 3D printing, and it saves a lot of time if you're doing a repetitive process like punching rivets out of these gym locks. Another work holding fixture that's out in our machine shop, this is another common 3D printing application, which is specialized jaws for a vise. So we have a cleat that we turn into a skiing shock for Valhalla, and in order to make this and prototype it, we took a regular cleat and then we cut it in half to make it a skiing shock. In order to do this, we needed a special fixture that would hold the cleat, that was perfectly the shape of the cleat. So we used the 3D model of the cleat and we made a fixture that was the negative of that. So we'll show that in the Bridgeport mill, that how we were able to set that up and perfectly hold that cleat and cut it to make those early prototypes that were production quality for Valhalla. And so those cleats actually made it out into the field and were made using 3D printed fixtures. In order to make the advanced prototypes of the 68507 skiing shock, we took the regular pull-up cleat and we put it in a special 3D printed fixture. It allows us to hold the cleat handle perfectly still while we're cutting the notch in between it that the skiing shock design requires. So here it is set up to show you how we would use this 3D printed part to aid the machinist in performing the perfect cut. Next category of tool is one of my personal favorites, that's drill guides. Traditionally, we've used paper templates for drill guides. It allows you to hold a piece of paper up to whatever it is you're trying to drill, and you can use it to locate the drill, but it doesn't assist the person using the drill in keeping the hole perfectly straight. And especially on a boat where there's a lot of curved surfaces, that can be difficult. Another place is really difficult is if we're cutting carbon fiber tubes and drilling holes in the tubes. The diameter of the tubes is small enough that the drill bit wants to walk around. So if we're going to drill any holes in a tube here for prototyping, or to add some sort of element, we'll make a special tool like this. So what we'll do is we'll make the printed part will be the shape of the tube that it goes over. We'll put like a landing here on the bottom so that it goes the correct distance away from the end of the tube. And then we'll have the bolt pattern that we need will be here. So whatever hole pattern we want to drill, we'll print into the tool and then we'll press these drill bushings in. So you can just install this on the pole and then freehand drill it, and it creates a perfect pattern of holes every time. This is really useful because this would just not be doable with any other method. Making this tool is very easy with 3D printing, but it'd be very difficult to do with traditional manufacturing methods. Here's an example of a drill guide that's intended for the boater to use on the boat. So this is beyond something that we use here in the shop for prototyping. This is an end retail product for the end user. This is a drill guide that allows you to drill the holes for a outrigger base. This has got one for each of the corner fasteners and then also a pilot hole for the hole saw that cuts out the middle. I developed this tool because I saw that a lot of the installations that people had problems with were due to inaccuracies in drilling. Again, because the surfaces are often curved, it can just be very difficult, even with a paper template, to get the holes just right. And if the holes are mislocated, sometimes it causes things like broken bolts. This is useful even for the end boat user, and ensures that the drilled holes are perfectly located every time. The last category of parts is, to me, the most interesting. This is something that is pretty unusual, even though 3D printing is pretty well accepted now, and that's functional 3D parts. A lot of 3D printers, your average hobbyist printer, is able to make complex shapes, but they're not very durable. We use a material and a process here that is both UV stable and strong. So this is an example of a part that we will ultimately make out of a metal, probably aluminum in this case, but this is a fully reinforced, completely 3D printed part that was installed on an outrigger project and actually used, ran out in the ocean. You'll see it's survived totally intact, and it's strong enough to perform the end goal just as if it were a piece of metal. This is hugely advantageous to us because machining time is big cost. If you have to quickly make something in a machine shop, it costs an exorbitant amount of money. With 3D printing, we can design the part, we can start the print, leave for the weekend, come back, and even a big piece like this is done, and it can go straight onto a boat and be tested. In this case, the metal part just looks better on a high-end product, and even though I think that the printed one would probably be fine long-term, we want to give people the aesthetic that they want, and some parts are just unfortunately not quite as beautiful printed as they would be out of metal. Other parts, however, are perfectly appropriate both cosmetically and functionally for long-term use. And there are certain cases where it doesn't actually make sense to open up a permanent tool when we can 3D print the part in production. So one example here I have is our flatline clip. This is a simple part that currently is a new product, so we're unsure as to exactly how much volume it would be. It would be very expensive if we wanted to right away open up an injection molding tool for this part and make it injection molded. So this part is a C-sucker body that we've just added a plate and a couple of little lanyard attachment points, so you can use a flatline clip and just use a C-sucker to attach it to the transom. This is a great example of a 3D printed functional part because it serves all the function that it needs to. It's UV stable, it looks good, and we're able to take it immediately to market in a low volume without having to incur a large setup cost. This is another example of a new product that uses 3D printing. So you'll recognize our gym locks. These are injection molded. This is a product that we now know is going to be sold in large volumes, so it makes business sense to open up the injection molding product. This is a brand new product, and these are 3D printed. So this body here and this part here are 3D printed, and you'll see that cosmetically they don't really look terribly different than the injection molded part, especially if you weren't really looking for it. And the good news is it's very similar material characteristics as well, strength, UV resistance, etc. So it can be at home, out on the ocean, being used in conjunction with an injection molded part, and it will never fail. This is something that we tested just this summer, and now we're able to offer to retail, and we don't have to go through the process of opening up a complex injection molding tool and figuring out exactly how long it's going to take to get it here in stock and make it. We can go straight to selling it at retail so that people can enjoy the product sooner.